Good morning or good afternoon. This lesson is going to be about simplifying numerical expressions with rational exponents. And it is part of our study of how we go about simplifying expressions that involve radicals. So, first off, we need to make sure that we recall some knowledge we have learned previously, which is how to interpret both a radical expression and its rational exponent form so that we can move back and forth between the two. So we have to remember that the index value in a rational exponent form, where you have a power that indicates your root situation, is the denominator value, and the numerator is the power or exponent on the radicand expression. If, in this case, the exponent is 1, therefore the numerator is 1. If we have an exponent such as some other value other than 1, here called p, with an index value of n, then we have p over n as our exponent. If we're simplifying, sometimes it's easiest to put the power of p outside, but that will depend on the expression, and we shouldn't ever have any final answers like this. If we have a power of p, it should be placed on the radicand and then simplified if possible. Alright, so we also will need to use our properties of exponents, which we have learned previously in the last 2 years. And so one of the things we have to do is understand structure. So recognizing the structure of an expression as a particular form that tells us then what the property is that allows us to simplify it. So these are here for our reference as we go through some problems. And they're in your guided notes. Alright, so here our instructions are to simplify each numerical value as much as possible. Sometimes that will be to an integer value or a rational number of some kind. Other times it will still be a power expression perhaps, or a root expression. So here in this case, we would have to recognize, and the parentheses around the 125 are optional. They indicate the base value, so this is equivalent to just 125 to the 4/3 power. So given this rational exponent, we have to understand that that denominator is our index value, which tells us the type of root we're working with, and that numerator is the exponent value, or power on the 125. Now, we're doing these problems without a calculator, so writing this problem as the cube root of 125 to the 4th power is problematic, because 125 to the 4th power is going to be a very large number. So here's a situation in which we would use the alternate form we looked at previously on our concept slide, that this power we can also place outside of the root and have the cube root of 125 inside. And then knowing our perfect cubes, we recognize, okay, the cube root of 125 is going to be 5, and that gives us 5 to the 4th power. The better we know our powers, the easier this is. If we don't know what 5 to the 4th is confidently, then we should do the basic math over on the side. But 5 to the 4th power is 625. So once we determine that, that would be our final answer. All right, next problem. All right, so here we have a negative exponent, and we have a rational base. We have a fractional base. Two things going on in this problem. Negative exponents can show up in any type of problem, so handling them is based on the negative exponent property and knowing when we would use that particular property. Fractional bases can also show up in any kind of problem with a positive or a negative exponent. And so we have to understand that what we're looking at here is that this power outside the parentheses would apply to both numerator and denominator. So here we're looking at, again, this negative value we should place with the numerator value of the 3, and that will become the exponent for both numerator and denominator. And the 4, which is the denominator, will be our index, telling us we're working with 4th roots. And that would be 4th roots of both numerator and denominator. So here we have the 4th root of 81, and the 4th root of 16. Each of those would also be raised to a power of -3. We would simplify each of those 4th roots. So again, the better we know our powers, then the easier this becomes. We may have to do some guess and check to determine them, but we want to make sure that we get the right value. So the 4th root of 81 is 3. So now we have 3 to the power of -3. And the 4th root of 16 is 2. So we have 2 to the power of -3. At this point, we should use our negative exponent property. And the negative exponent property, remember, says that if we do the reciprocal of the power, it changes the sign on the exponent. So if I move this power to the denominator, the exponent will become positive 3. And if I move this power to the numerator, the exponent becomes a positive 3. So now what I have is 2 to the power of 3 in the numerator and 3 to the power of 3 in the denominator. At this point, I can evaluate. Remember, you cannot evaluate negative exponents because what they mean is reciprocals, not negative numbers. And so 2 cubed becomes 8, 3 cubed becomes 27, and that would then be our final numerical value. All right, moving on to the next one. So now here we're looking at a product of two powers. And recognizing this structure tells us that we would use that particular property, product of powers property. The bases are the same. So we're looking at using a property that would be like x to the power of n times x to the power of m has a new power of x with a new exponent of the sum of the originals. So this would then become a new power of 25, and we would add the exponents of 3/5 and 7/5. Now, given that this is addition of fractions here, if we had different denominators, remember, we would have to get a common denominator before combining them. Here we have a common denominator of 5, so we would add the numerators, and that would give us 10 over the denominator of 5. Then we have to recognize we don't want to treat this as a power and an index because we can simplify this. This is 10 divided by 5, which gives us 2. And so this actually becomes 25 squared. So we simplify as much as we can with our values, and then we decide what would be appropriate next. So then 25 squared is actually 625. It's equivalent to 5 to the 4th power, in fact. And that would be our value. All right, and this one. So here we are looking at a quotient of two powers. And so basically that tells us this structure tells us we're going to use the quotient of powers property to simplify. So the quotient of powers property says if we have a quotient of powers where the bases are again the same. So these properties only apply when bases are the same. That we can combine those into a new power of x in one of two ways. We can either combine them by subtraction. It's always through subtraction, but if we start with the n, that would pull our new power of x to the numerator. If we start with the m, it would pull our new power of x to the denominator. And remember that these ones here are not, it's not a ratio or anything, it's the coefficients that remain. So this one is what's left there, and the one here is what is left there in that form. So now I'm looking at, okay, well, I've got this. Well, which one do I want to start my subtraction with? Well, I want to start with the larger one because that will give me a positive value, and that way I don't have to also use the negative exponent rule. So I need to know which of these is larger. And your number sense may tell you 5, 6 is larger. If not, you can get a common denominator first, and then you compare the numerators. You can tell that way. So your lowest common denominator for 2 and 6 would be 3. So I will the lowest common denominator would be 6. So I need to multiply 1/2 by 3 over 3. So this now gives me 8 to the power of 3 over 6. And my denominator is still 8 to the power of 5 over 6. So now that the denominators are the same, we can also see 5, 6 would be larger than 3, 6 because 5 is larger than 3. So I'm going to start my subtraction with this exponent in the denominator. So this is now going to become a new power of 8 in the denominator with an exponent of 5, 6 minus 3, 6. And then here I am going to get my 1 because this is like 1 times that power, and so that now is a 1. Then what I'm looking at, of course, is subtracting numerators with a denominator of 6. So I have 1 over 8 to the power of 2, 6. And again, I don't want to treat this as an index and a power yet. There is not going to be any 6th root of 8 I can do, but I should recognize 2 6 can be reduced. And so now what I have would be 1 over 8 to the power of 1/3. Now that I should recognize is going to become a root that I can deal with. Index of 3 tells me I'm dealing with the cube root of 8 to the 1st power. And so that would just be 8. and the cube root of 8 is 2, so that gives me the fraction of 1/2 as a final value. All right, let's take a look at this one. So here we're looking at the situation, we call this power of a power. So this power here is applied to the power, base, and exponent inside the parentheses. So that tells us we're using power of a power property. Power of a power property, if you recall, tells us that if we have this structure, that we would combine these exponents into a single exponent through multiplication. So here what I have is 32 to the power of 4/3 times negative 3/5. And so in this case, I can reduce a little bit. My 3's will reduce to a 1 and a negative 1. And so now what I have is 32 to the power of negative 4/5. Now I would treat this as rational exponent, where my index is 5, my power will be negative 4. So again, the structure I would use would be to, in this case, since I'm simplifying, put the power of negative 4 outside the parentheses around the root. Because I can simplify the 5th root of 32, which would be 2. And now I have 2 to the negative 4th power. Now I would have to recognize, okay, well, negative exponent rule says this would be the reciprocal, so this would become 1 over 2 to the 4th power, and that would then become 1 over 16, and that is my final value. So that is all of our examples. And so what we've talked about here should be able to apply to all of the problems that you'd be expected to simplify, knowing what that you have looked at and just applying whatever is necessary to each problem. All right, you may begin your assignment. See you tomorrow.